Hello, this is Mrs. Grizzoffi. We are on 11.02 Geometry Notes. We're going to continue talking about volume today, a little bit about density as well. So we're still talking about those formulas that you have on your reference sheets, that the Regents reference sheet that you will have access to. So I just made a note of when they're given on the sheet. That's what the given means right here, that it is written out for you on that reference sheet. So it's not one that you have to memorize. So this first one we're going to start with is a cone. Think of like an ice cream cone. And the volume of that is 1/3 pi r squared h. So remember, your area of your cylinder was area of the base times height, or pi r squared h. And so we're taking 1/3 of that. So this volume of the cone would be 1/3 of the cylinder. A couple things you need to know here. The bottom here is a circle, which means it has a radius and a diameter. We also have a perpendicular height drawn from the apex of the cone, which is just this top point right here. I don't know if you guys watch the news right now, but you hear a lot about the apex when they talk about the coronavirus. And that right here is your perpendicular height. So what's interesting here is that with a cone, we have two heights. We have the perpendicular height, which means it's perpendicular to the base. We also have a slant height right here. In green, that is your slant height. That just goes along the outside of the cone. So what's helpful here is occasionally we might ask you to use the slant height or use the perpendicular height. And if you know the radius, these all make a right triangle. So if you have 2 out of 3 of them, you can always use Pythagorean theorem to find the third. So that's something important to remember. And when we talk about the cone, 1/3 pi r squared h, that is talking about your perpendicular height. Number 1, given the radius of a cone is 15 centimeters and the slant height is 25 centimeters, find the volume. So here's my cone. I'm going to label, I know the radius is 15 centimeters and the slant height is 25. So along here is 25, radius is 15. I want to find the volume. So the volume, write out my formula, 1/3 pi r squared h. And I need to know my perpendicular height, which I was not given. So I'm going to draw that in here. So how to find the perpendicular height is what I was saying before, is that they make a right triangle. So I can use Pythagorean theorem here to find my height. So I'll do it off to the side here. So I'm missing my h, which is a leg. So it's going to be 15 squared plus h squared equals 25 squared. So go ahead and type in your calculator and then do your subtraction. If you need to, pause the video to figure that out. And you should end up with h equals plus or minus 20. Since it's a height, we want to reject that negative. So h is going to be positive 20 centimeters. Now I know h. I know my r is 15. So I'm just going to substitute in. So 1/3 pi times my radius is 15 squared. Another thing they could trick you with is giving you the diameter instead of the radius. So just remember to divide by 2 if that's the case. So now we're going to do 15 squared to get 225 and multiply that by 20. And actually, I would type in this, and this all into my calculator at once. So everything except the pi. And that should give you 1,500. Bring along your pi. And this did not say to round. So if it doesn't say to round, you want to leave it in terms of pi. If it doesn't say to round, leave exact. Exact means in terms of pi for this case. Or Other times it might mean in simplest radical form. And our units here would be centimeters cubed. Okay, and that's it for number 1. That's a cone. Let's talk about a pyramid now. So a pyramid looks exactly like you might think, like a pyramid. It can have a different shaped base, which is what's interesting here. So it could have a rectangular base, it could have a triangular base. And what's different here is it always comes to an apex. So some people get these confused with prisms. Remember, a prism has 2 congruent parallel faces as its bases. And this does not have, so if this is our base down here, because it's sitting on that, it does not have a congruent base that's parallel to that. It comes to this apex again up here. So again, if we drop straight from the apex down perpendicular to that base, we have our perpendicular height. And again, along the edge of the figure, if you go straight down the side on the outside, that's going to be your slant height. So we have 2 different heights again. The formula, which is given on the reference sheet, is 1/3 capital B times H. And remember that if the B is capitalized, it means the area of the base. And this H, again, is your perpendicular height. Let's do an example. Find the volume of the square pyramid with a height of 12 inches. So this tells us if it's a square pyramid that this, even though it looks rectangular, is a square. So each side is going to be 10 inches on that bottom. So when we do our volume, we take 1/3 the area of our base. Well, what's the shape of your base? The base is a square. What's the area of a square? The area of a square is side squared, or base times height. So we do s squared times the height, perpendicular height of our pyramid, which they gave us was 12 inches. So now substitute in. We know that each side of the square is 10, so that's 10 squared times 12. Type that right into your calculator. Gives you 400, and this is volume again, so it's inches cubed, because you have the 10 inches times 10 inches times 12 inches. That's 3 inches you're multiplying together, so cubic inches. And lastly, for our figures here, we're going to talk about a sphere. A sphere is, a circle, 3-dimensional. So if you spun a circle around its axis, it creates a sphere. The volume of a sphere, again, is given. So all 3 of these formulas that we're talking about today are given to you. You don't have to memorize them. They're equal to 4/3 pi r cubed. Now, we also talk a lot about hemispheres. So a hemisphere is just half of a sphere. So if you took just the half, would be the sphere. The one that is not given to you is surface area of a sphere, and that is 4 pi r squared. So that one you'd have to memorize. So try to remember r squared for square units, since it's surface area, where volume is cubic, so that's r to the 3rd. All right, number 3. Find the volume and surface area of the sphere with a diameter of 9 feet. Find the exact value. All right, so let's first find the volume. So volume is 4/3 pi r cubed. It gave us a diameter of 9 feet. We want the radius, so we want to divide 9 by 2 to get 4.5 feet. Now we just substitute that in. So we've got 4/3 pi, and then our 4.5 cubed. Type that into your calculator. It says exact value, which means in terms of pi. So I'm going to type in my calculator 4/3 times 4.5 to the 3rd. And it gives me 121.5, then bring along my pi, and that's going to be feet cubed. And then we were asked for surface area. So that's going to be our formula. This one we do have to memorize, 4 pi r squared. We already found our radius, so really at this point it's just substituting in. Hardest part here is knowing your formula. Type it in your calculator. Again, we want it in terms of pi, so you're going to do 4 times 4.5 squared, which will give us 81 pi, and that'll be feet squared. So those are the 3 main formulas. That kind of wraps up our volume formulas for us. So we're going to look at one more thing today, and that is a little bit about density, which I know you guys talk about in science. You may have done a little bit of it in math as well. I think a lot of you guys already know the formula. Density equals mass over volume. I always remember it as DMV. D equals M over V. And one thing that I think in science you guys have talked about before, that if you have a density that's less than 1, it means that your object will float. If you have a density that is bigger than 1, then it would sink. So I always think like bigger things might, well, that's not true, but if you're bigger than 1, then you might sink. So you'd sink to the bottom if you're bigger than 1. And if you're less than 1, you float nice and light. You're going to float on top. Obviously, density is not talking about just the weight of an object, though. The density is your mass over your volume to figure out if it'll float. Because if we thought about if just heavy things always sunk, then big boats would not be able to float on the water. Number 4 says, if a basketball has a diameter of 23.9 centimeters and a mass of 620 grams, will it float? So let's find the density. So density equals our mass over our volume. So we know that this is a basketball, so that would take the shape of a sphere. So our mass over the formula for our sphere is 4/3 pi r cubed. So we want to find 620 grams over 4/3 pi. Our diameter is 23.9. So our radius, we're going to divide that by 2, will give us 11.95 cubed. And then type that into your calculator, and you could actually type that whole thing right into your calculator, or if you want to do the bottom first and then do 620 divided by that answer. If you did that, the bottom is 2,275.319833 pi. So you could do it that way, and you should end up, I'll let you guys type it in yourselves, but you should end up with 0.8673599949, which is less than 1. Therefore, yes, it will float because the density is less than 1. All right, number 5. Tennis balls are sold. So these next two are little trickier problems. They are Regents questions. I left the choices on for multiple choice, but they're quite a bit of work. It's kind of, ignore the choices first and figure out the answer, then look at your choices. So tennis balls are sold in cylindrical cans with the balls stacked on top of one another. So we've got a tennis ball with a diameter of 6.7 centimeters. To the nearest cubic centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? So you've got, again, I'm not very good at drawing here, but we've got a tennis ball here. 2, these are pretending to be all the same size. So here's your tennis balls. Kind of look like smile faces, not very good. And here's our, sorry about my drawing, but this is my tennis balls inside of, you guys probably have much better drawings here. The tennis balls inside of our can. Okay, we want to know the volume of the can. So we know the can is cylindrical. So the volume of a cylinder is area of the base times height, or just pi r squared h. And that one's given to you. So in order to find this volume, I need the radius and I need the height. Well, the radius of our tennis ball, well, actually, they give us the diameter of our tennis ball is 6.7 centimeters. So 6.7 divided by 2 would give us 3.35. So I know the diameter of the tennis ball is 3.35, and we're assuming that this is the container is pretty close. It's right up against those tennis balls. So that's going to have the same diameter as the tennis ball, which would be 3.35 for our radius. Now we need the height of that whole container. So if I know the radius over here is 3.35, well, let's look at this one. So we know this is 3.35, then I know if it's a sphere, the radius at any point is 3.35. So if this is 3.35 and this radius up here is also 3.35, then that's my diameter right here. And I was given the diameter is 6.7 centimeters. So I have 6.7 centimeters for this ball, 6.7 for this one, 6.7 diameter for that one, and 6.7 for this. So I've got 4 balls, each with 6.7 centimeters of a diameter. So if I multiply those together, that gives me 26.8 centimeters for the height of my can, because my can starts and stops right at the bottom of the last ball up to the top of your first ball. So we know our radius of our can is 3.35, and we know the height of our can is 26.8 centimeters. Also on these, always really be careful about your units. Sometimes they switch it up on you. So we know centimeters here, they're asking to the nearest cubic centimeter. So now we can just substitute in. They didn't change any units on us here. So 3.35 squared times 26.8 pi. This one wants it to the nearest cubic centimeters. So, oh, I've got too many pi's in here. We want to just type in this entire thing right into your calculator. So if you need to, pause the video, type it in. All right, and we should get 944.874813, which is approximately 945. Last one, a hemispherical water tank. Hemispherical, what does a hemisphere mean? That's right, it is half a circle. I heard you guys shouting that out. So again, you know I'm really good with my pictures here. So that's my hemisphere, half of a circle. And we know that it's a pretty cool water tank, first of all. And the inside diameter is 10 feet. So if the inside is 10 feet of the diameter, that means my radius must be 5 feet. Water has a density of 62.4 pounds per cubic foot. What is the weight of the water to the nearest pound? Okay, so here we are given this tank. We know the density of the water. We want to find the weight of the water in this tank. So first we need to figure out, well, how much, what's the volume of the water in that tank? So we need to take the volume. We only know the volume of a sphere, but a hemisphere is half that. So we're just going to take the volume of a sphere and divide it by 2. So we've got our formula for the volume of spheres, 4/3 pi r to the third. We're going to divide that by 2. Let's substitute in. 4/3 pi, we said our diameter was 10 feet, so our radius was 5 cubed. Type that into your calculator, pause the video, type it in, see if you get the same as me. Okay, we got 261.7993878, and that is feet cubed. So that's our volume right here. That's the volume of the tank. So how much water is in there. We want to know what's the weight of the water in there. So I know that the density of the water is 62.4 pounds per cubic foot. So if I write this as a fraction, that would be 62.4 over 1, 62.4 pounds over 1 cubic foot. I want to find how many pounds the water is. Well, I know that the volume, which is also in feet cubed, is 261.7993878. So if I multiply these together, my feet cubes will cancel out, leaving me with pounds. So that's feet cubed. So kind of like your dimensional analysis thought process here. And now we'd say, okay, well, these feet cubes cancel. So now I'm just really multiplying 261.7993878 times 62.4. So you're taking the volume of the tank and multiplying it by the density, which will give us our weight in pounds. So that should give you 16,336.2818, and that's pounds. It says to the nearest pound. So we have got choice A here, to the nearest pound if we round it. So again, we're looking at our density here. Density, you could also think of it as density equals mass over volume and do it that way as well. Okay, that is it for today. I hope you guys have a great day and staying healthy and loving math, and pie out.